Hi, this is our phase 1 project demonstration for the data engineering pipeline. This is our GitHub repository which contains all that required necessary information of files. So we have the schema.sql file for the database design. We have the ingest data.py, which is a Python file for the ingestion pipeline, and security.sql for the role-based access control, where we have given two roles as recommended, and the three enough justification document. It explains our design decisions. These are the files or deliverables for the phase 1 that are organized and available here in the GitHub repository. And going with the ERD diagram explanation, I'll zoom out a little. This ERD represents the structure of our database. It includes the nine main tables such as customers, orders, order items, order reviews, payments, and products, sellers, product category translation, and geolocation. Each order here is associated with the pay. Each order is associated with the payments, optionally a review, and we also have a separate geolocation into its own table to avoid the redundancy and maintain normalization. Overall, the schema is designed in the three enough to eliminate the redundancy and ensure data integrity. So next, going with the schema.sql, I'll just open the file. This file defines all the tables along with the constraints. Each table has a primary key and its relationships, which are enforced using the foreign keys. We also use check constraints to enforce the domain rules. For an example, if you take an order status which is limited to a predefined set of values. So these constraints ensure data consistency and prevent invalid data from being inserted into the database. So that is being taken care of it. And now I'm just going to the ingestion data Python file, and I try to run this file. I've already ran this file previously, but I'm running again. So basically this script reads raw CSV files, cleans the data using pandas, and loads it into the um, PostgreSQL database using the SQLAlchemy. The data is inserted into the correct order to maintain the foreign key dependencies, which is the pipeline is also um, it avoids the duplicate records if we run multiple items. Okay, so as we see that the Python file has been completed, now we go to the Neon console. This is the SQL editor in the Neon console. So I just show you a random SQL query. I'll just use the count aggregator function. So we can see this confirms that all records have been inserted correctly. So I'll go into the monitoring. So finally, this is the Neon monitoring dashboard we use to track compute usage. As shown, it is very well within the free tier limit. The graph shows only brief spikes during ingestion followed by no continuous activity. You can see it drops down, and I just ran here and it spikes up and it just follows. So we configured and we also configured SQLAlchemy using the null pool, which ensures the database connections are not kept open. So just so this ensures when the database is idle after execution, it automatically passes and prevent unnecessary computing usage. So that's all for the phase one. Thank you so much.